For many years now, Bill Nye, known affectionately to many as the man of science, has inspired awe and curiosity as he helped audiences everywhere make sense of the latest scientific discoveries. His explanations have made the strange and often intimidating world of space and physics feel just a little more familiar. Over time, he's played a key role in deepening our fascination with the vast, mysterious expanse of the universe. His work has helped us better understand not only the cosmos but our place within it. From the grand mysteries of the final frontier to the intricate beauty of distant galaxies, he's encouraged generations to keep looking upward. Now, Bill Nye is speaking out about one of the most transformative developments in modern astronomy, the recent observations made by the James Webb Space Telescope. These images don't just give us a look at beautiful cosmic scenes. They reach deep into the fabric of space and time, offering glimpses of a universe as it existed more than 13 billion years ago. These revelations are not just reshaping our scientific models. They are challenging our fundamental understanding of reality and even what it means to exist. The telescope itself is already being seen as a defining breakthrough in space science, an instrument of discovery that marks a new chapter after the legendary Hubble Space Telescope. Webb is not only detecting light from stars and planets beyond our solar system, but also revealing intricate details about their composition, structure, and history. It's helping scientists understand the origins of galaxies, the birth of stars, and the ingredients that might make a planet suitable for life. So what exactly are we seeing in these new images that has surprised experts and defied old theories? And what insights does Bill Nye offer as we interpret this data? The journey to this point began with a colossal engineering and scientific effort. NASA and its partners spent years designing, building, and testing this advanced space observatory. Finally, on Christmas Day in 2021, the James Webb Space Telescope was successfully launched into space. Its deployment, a complex and risky process involving the careful unfolding of mirrors, shielding, and instruments, unfolded over several months with remarkable success. By June 2022, scientists had already begun examining what it had captured. And what they found was extraordinary. Thousands of previously unseen galaxies were detected. Many of them are much older and more distant than those we knew of before. Some may have formed as early as 150 million years, before even the oldest galaxies observed by Hubble. Webb's advanced sensors are capable of collecting incredibly faint signals of light from far-off objects, allowing it to analyze their compositions and paths. According to Bill Nye, these findings are more than impressive. They're opening the door to entirely new ways of understanding how galaxies and stars evolve, and what conditions might allow life to emerge elsewhere. One of the most iconic structures, captured by the Hubble Space Telescope, is the so-called Pillars of Creation in the Eagle Nebula. These towering formations of gas and dust have long fascinated scientists and the public alike. Hubble revealed the structure in visible light, but it couldn't penetrate the dense material to show what was happening inside. Webb, equipped with its powerful infrared instruments, has now captured something more: the process of star formation within those very pillars. The image shows what are known as protostars, clumps of gas and dust that are in the early stages of becoming stars. They appear as tiny red dots scattered throughout the image like glowing embers in a cosmic furnace. Each of these forming stars is enormous, many times larger than our own solar system, and not yet hot enough to begin nuclear fusion. But according to Bill Nye, that changes as more material gathers at their core. The increased mass leads to higher pressure, and eventually, the star's core reaches a critical density. At that moment, hydrogen atoms begin to fuse, creating helium and releasing tremendous amounts of energy. The temperature skyrockets to around 2 million degrees Celsius, marking the true birth of a star. The colors in the image aren't just beautiful. They also tell a story. Each hue represents a different infrared wavelength which our eyes cannot see. Only the blue portions of the image fall within the range of visible light. The reddish tones represent much longer wavelengths, about 6 times what the human eye can perceive. As Bill Nye points out, this infrared view not only highlights the power of Webb's instruments, but also gives us a front-row seat to the dramatic formation of stars like our Sun. billions of years ago. The telescope isn't just looking at stars and galaxies, it's also studying exoplanets, or planets that orbit stars beyond our solar system. Since the first discoveries in the 1990s, we now know of more than 3,000 confirmed exoplanets. However, most of these have never been seen directly. Because they are so far away, scientists usually detect them by observing slight dips in the light from their parent stars as the planets pass in front. Direct images are incredibly rare and difficult to obtain. But in September of last year, the James Webb Space Telescope captured a direct image of an exoplanet called SHIP 65426b. Originally discovered in 2017, this planet is huge, about 12 times the size of Jupiter, and is located far from its host star, about 100 times the distance between Earth and the Sun. This extreme separation, combined with Webb's advanced infrared sensitivity, made it possible to block out the star's bright light and capture a clear image. Using coronagraphs and multiple high-precision cameras and filters, scientists were able to observe this massive gas giant directly, an extraordinary achievement. Webb has also turned its focus toward galaxies, including the faint and elusive Ghost Galaxy, also known as M74. Though barely visible in the night sky, its structure becomes strikingly clear when observed in the infrared. The telescope revealed thread-like structures of gas and dust spiraling out from a bright core, all rendered in a vibrant electric blue. Along its spiral arms are active regions of star formation, glowing brightly in Webb's powerful images. Scientists combined data from both Webb and Hubble to create a stunning composite image that blends visible and infrared light. This was part of the FANGS project, a collaborative effort involving the European Space Agency and ground-based telescopes. Their goal, to study 19 nearby galaxies in unprecedented detail, identify star-forming regions, measure the mass and age of stellar clusters, and even examine the tiny dust particles that drift through interstellar space. Another fascinating discovery came from an image of a distant star called WR140, taken in July last year. While most space photos contain some imaging artifacts, like diffraction spikes, this image revealed something different, a series of symmetrical wavy rings surrounding the star. These are not optical illusions or malfunctions. Rather, they are real structures formed by the interaction of WR140, a Wolf-Rayet star nearing the end of its life, and a smaller companion star. As the massive star sheds its hydrogen and releases powerful stellar winds, it interacts with its partner in a way that creates these concentric patterns. It's a rare and eerie glimpse into the final stages of a star's evolution. Webb has also reached deeper into time and space than ever before. In mid-December, astronomers announced the detection of 4 incredibly ancient galaxies, some of the oldest ever observed. These galaxies existed when the universe was only 350 million years old, about 2% of its current age. Using the near-infrared spectrograph, scientists measured the galaxy's redshift, a stretching of light caused by the expansion of the universe. The highest redshift measured was 13.2, confirming the galaxy's extreme distance and age. These discoveries were part of a major effort called the JADES survey, which uses Webb to study the early universe. The ability to both locate these ancient galaxies and verify their distance is a major leap forward for astronomy, and the telescope isn't finished yet. Another groundbreaking study focused on a planet called WASP-39b, located in the Virgo constellation. This gas giant, about the size of Saturn, orbits its star extremely closely, 8 times closer than Mercury is to the Sun. Because of this proximity, the planet experiences extreme temperatures and violent atmospheric activity. Scientists found that its clouds are rich in sulfur and silicates, including sulfur dioxide. By using 2 of Webb's spectrographs, they also detected carbon dioxide in the planet's atmosphere. These detailed atmospheric readings are giving us new tools to evaluate the potential habitability of distant worlds and understand how planets form and evolve. Each of these discoveries, whether they involve galaxies, stars, or distant planets, offers a deeper insight into the vast, complex, and beautiful universe we inhabit. The James Webb Space Telescope is not just capturing images, It's capturing history, billions of years old, and bringing it into focus like never before. As Bill Nye emphasizes, we are entering an era where we're not just exploring space, we're beginning to truly understand it.